everybody to the Friday of week 2. Day 2, technically. So we're going to continue our discussion of proper class design today. Before we do that, there's something I mentioned in the previous class that probably you guys should know about too. The transfer requirements are changing. I don't know the date that they're going to happen. That probably won't apply to you. But there's a bill that passed the California state legislature that is going to make everything IGETC, which is the UC transfer system. So there's probably going to be some changes coming to how community colleges, CSUs, and UCs interoperate in the next couple of years. So just pay attention to that for now. I mentioned that because in the previous class, one of my former students, Muya, who's at UC Irvine right now, is having to retake 40 and 41, which is really kind of absurd because he's passed them already, but it's in Python, so he gets credit for more advanced classes and has to take more basic classes. So it's kind of a ridiculous situation. So hopefully there are some issues with the law and how it's implemented. It's getting rid of speech requirements and things like that. But we'll see how it shakes out. It might work out all for the better, right? So you go to a community college and then you just transfer in as a junior. That would be amazing. UC or CSU, that would be really cool if it works out that way. As it is, from what I hear on the grapevine, I haven't read it myself, is that there's some issues with that. So, you love my background? Oh, you know what it's from? Scam. Yeah, so, great new rules. Let's see how it plays out. Yeah, unfortunately, the debate takes place after it's passed instead of before, which is a bit unfortunate, so. Nerve, yeah, very good. Nerve, yeah. All right, so let's do this. I did want to mention that though, just because I mentioned it to the previous class, and I try to keep the knowledge level of both sections the same. So what we're going to be doing today is we are going to be doing more proper class design. Yay! Okay, and so today I'm going to go through the construction of a circle class for you guys. And then in lab time, you are going to make a rectangle class. So what is a class? Like, why class? Why do we make a class, right? A class is data plus operations we can do on that data. Okay? So for your next homework assignment, you are going to be making a fraction class. A fraction is a numerator and a denominator, and then there's operations you can do on that fraction, like print it to the screen, read it from the keyboard, add two fractions together, reduce a fraction, that kind of stuff. And that's what you're going to be doing for your next homework assignment, is you are going to be fleshing out a fraction class that I've sort of half written for you. So it already has the private member variables and public constructors and things like that. It's like a skeleton designed to kind of get you to flesh out the skeleton so you can kind of see how the process works without needing to do it all from scratch. That'll be due next Friday at noon. Okay, but today we are going to go over proper class design again, more. Okay, so if you recall, in general we start with private member variables that describe the thing, right? So for a can't type and talk at the same time. So for a circle, what things are needed to describe a circle, mathematically speaking? Right? Like if I tell you here's circle A and here's circle B, both of them are going to have 360 degrees. Both of them have one side, so to speak. Usually sides are considered straight lines, though. Area, okay. Diameter. But if I'm telling you, like, here's a circle, like I'm gonna, like I've got a thing, and I'm trying to tell you, like, hey, draw this circle for me. What numbers do I need to give to you so you know what kind of circle and where it is on the Cartesian plane? Center point and radius. Yes, that is exactly correct. So we could do this. We could say float radius. And we could say float x location and y location. But since the x and y location kind of go together always, that's more appropriate to be a pos. because pods are okay in the, if it calls for it. Right? There's a lot of nice things about pods, which we will see, pods that we will see in this lecture. So I'm just going to make a struct called vector2d, and it is going to have a float x and a float y. And I'm going to initialize x to 0 and y to 0. I'm going to initialize radius to 0, and here we are off to the races. So the circle is going to have a radius, pods, plain old data. Yeah, so plain old data structure. And you'll sometimes see it called pod, plain old data. And this is actually a term in C++. Like there's actually an isPod function in the standard library that'll tell you if something is a plain old data or not. Because the language actually works a little bit differently for pods as they do for these things, which are called ADTs. So, so we got the radius, and then we need the center point. So we're going to have a vector 2D called the point, or the center. And this is, the center point of the circle, and that's the radius. And now we have described a circle. Okay. So if I give you x, y, and radius, that will uniquely describe a circle on a 2D Cartesian plane. So we start off private member variables to describe the thing. Okay, check. Step 2, constructors. And destructors if you allocate in the constructor. For this one, we're not going to allocate memory. In other words, if you new in the constructor. We're not going to new anything. We've got 3 regular variables here. So we don't need a destructor. So I need a public session. And then public session is going to have the following. A constructor. A constructor is a class with the same name as the... it's a function with the same name as the class. So in this case, circle. And I can actually just leave it empty if I want. And the reason why this is fine is because I'm using the equals 0 stuff here, and here, and here. And so if I just make a circle named Bob, circle Bob, and, well, I can't see anything, it's private, but basically Bob's radius is 0, Bob.x is 0, and Bob.y is 0. Okay? So this is something called the default constructor, called when no parameters are passed when you make a circle. Okay? That makes sense? So when we call circle Bob, we're not saying circle Bob equals 5 or whatever. We're just saying circle Bob. So that is going to call the default constructor. Are you guys with me on this? Excellent. I have one person who's on board with this. Okay. 3 people now out of the 40 watching the stream right now. Excellent, excellent. There we go. Thank you. So, usually though, we want to have the constructors take one parameter for each of the private member variables we have. So we also want to have a circle taking a float new radius and a vector 2D new center. Now, before I move on, should this be passed by value, like I'm doing? Should it be passed by reference? Should it be passed by const reference? What do you think? Whenever you pass a non-primitive, what's the right way of doing it by default? Is circle just constructor syntax? Nope, that's a function body. It is an empty function. Absolutely nothing takes place here. And the reason for that is because I have these things here. Now, back in the day, prior to modern C++, you couldn't do this. Everybody wanted to do this, but you couldn't do it. And so the default constructor would say, like, radius equals 0 and that kind of stuff. But this is actually kind of preferable. Because no matter how many constructors you have, it'll always default to 0 if you don't set it otherwise. Const reference is the right answer. So we want to do a const vector 2D by reference, new center. And we are going to set radius equal to new radius. And we're going to set center equal to new center. Okay. And so now we could create Bob with 5 as the radius and a center point of 10.1 and 20.2. Okay. So Bob's radius is 5, Bob's x value is 10.1, and Bob's y value is 20.2. And if this looks a bit weird to you, it's because that right there is a vector 2D. This is actually one of the really nice things about using a pod, which is that you can actually initialize it using curly brace syntax. And so this constructor takes 2 parameters. The first one's a radius, the second one's a vector 2D. And so I can pass in the radius, just, it's a float, or it's an int, but you can pass ints to floats, it's fine. And then for the vector 2D, I actually just pass in curly brace the x value, comma, the y value, and it just works. And the only reason why it works is because it's a pod. So that's why I said pods are okay. There's times where you just want to have a couple of variables like living together. X and y always go with each other, so they should be put into a struct, philosophically speaking. Nobody's going to stop you if you want to just have float x and float y here instead of center, but it opens up the door for like returning a point and accepting a point instead of always having to do them as 2 different parameters. Okay, so this is going to set Bob's radius to 5, Bob's x to 10.1, Bob's y to 20.2. All right, next step, we can add a destructor, but we don't need this, so we should delete, I guess. If you don't need a destructor, don't make one. It'll make an empty one for you. So I'm only putting this there to remind you the syntax of a destructor, which is tilde, then the name of the class, no parameters are given to it, and then inside of the function body, because this is a function, right? You would delete, the array you allocated or whatever, but we don't need it, so there's just nothing there. So again, this is just literally an empty. It's just literally just an empty function body. Open close parentheses. Doesn't do anything. What happens if you make the constructors private? It won't compile. Okay. So yeah, because you're trying to call a function. It's a private function. Sorry, you cannot access private variables from main. Right. Private variables can only be and private methods can only be called from inside of circle. Right. What about the pod? What about the pod? Everything's public here. Yeah. Yep, it is public. What's your question about it? Okay. What if it was private? Then everything would explode. This is pointless. Okay. Having a all private pod is, I don't like, there's niche cases for everything. If you wanted to allocate enough memory to have 2 floating point numbers, but you didn't want to ever touch the data, you could use a private pod, I guess, and then you get 8 bytes of memory. I don't know. I've literally never done that. There are some uses for like private constructors. Like if one constructor is going to call another constructor, but that constructor shouldn't be visible to main, then you can make it private and sort of chain them together. There's some reasons to do that sometime. I don't think I've ever done it though. Radius and circle classes default to private. Yes, this is private. In classes default to private. So you don't need that. Okay. Bottom line, constructors are public, yeah. Public session, constructors. Okay. Next step is going to be getters and setters, sometimes called accessors and mutators, which is kind of a cool name if you ask me. Accessors and mutators, and there's other get set methods, like I've seen it called different ways. Basically, we can't really do anything with this class. Like we've made Bob, but if we like try saying cout.bob.x, it won't work, right? Because it's, or radius. It doesn't work because it's private, right? Radius is a private member, can't do it. So if we want to be able to get at the radius, we need to have a get method. And that method will return the radius. Now, so it's going to be a function that's going to return a float, because radius is a float. And it's going to be called get_radius, takes no parameters, and it will simply return the radius. Do the same for the center. 6s, center, and dot. And now we've got the ability to say cout.bob.get radius. And then I'll put 5. Because Bob's radius is 5. You guys see how that works? Now, this might seem like a lot of extra work. Like, why not just use bob.radius? And there's a really important reason for that, which is that classes have invariants. Invariants are rules that cannot be broken. I was going to say promises, so it came out as broken. Promises, rules, contracts that cannot be broken. So for example, for a circle, does it make sense to have a circle with a negative radius? Nah. Doesn't to me. And you might be like, well, why don't you use an unsigned float? Well, you know, if it existed, that'd be one thing, but they don't exist. So, so you have to enforce it. So anytime the code tries to enforce the rule, anytime main tries to set radius, we need to block it if it tries to set a invalid radius. And we could either clamp it to 0, or we could throw an exception. It depends on your philosophy. So for example, down here, we could say if radius is less than 0, we could throw a runtime error saying radius can't be less than 0. Okay. So that works fine. But if we try setting Bob's radius to -5, then when we do it, it throws an exception. We don't catch it, kills the program, and it says, yo, radius can't be less than 0. Don't do that. Cool. We've now enforced this contract. We've made a promise that radius is always non-negative. All right? And so if all you had was a pods, right, and people could just be like, bob.radius equals -5, you can't enforce that contract anymore. Classes are all about these invariants. If you don't have any invariants in a class, it probably should be a pods, right? Like for this, we literally don't care what value x and y should have, right? -100, 500, 0.2, we don't care. So who cares? We don't need a getter or set method. Just .x, .y, it's fine. Because there's benefits to using pods. Like there's things where you can do things like this. You just like do it. So when we write our set method, set radius, it's going to take a new float called new radius. We need to enforce this contract. So we're going to say if the radius passed in, the new radius you want us to have is less than 0, then copy paste that and just make you new radius. And so if they try changing it after the fact, like let's say they make Bob, and then later on after the fact they say bob.setRadius to be -10, then that also will throw. Okay. And kill the program. You guys understand? And then if it passes our check, our sanity check, our invariant enforcement mechanism, whatever you want to call it. If it's an okay, we vetted the input, it's all right. Now we go ahead and take it into our heart, and our radius is now 7 or whatever. Okay. Do you guys understand this concept? Like, this is why we go to all this rigmarole, right? I can set the radius of Bob to 70. I can't set it to -5. Yeah, and so it enforces rules. Whereas, you know, with like a pods, you can just set it to -70. You just have, and you would have no way of knowing that your invariant's been violated, right? By giving it an interface like that the outside code always goes through, you can set up checkpoints and be like, papers please, and be like, oh, -5, that's not allowed, throw an exception, you know. 70, come on in, you know. And so you can enforce the rules. That's why we go to all this effort. And in part, it's because of separation of concerns, which we talked about last time, so that one person can work on the circle class, and if they ever want to modify the circle class, like let's make it a double behind the scenes. Nobody in main needs to know about it. They don't need to know. As far as they're concerned, they're still getting a float, and they're setting a float. They don't know that it's a double behind the scenes. It allows me to make changes through this barrier, this opaque barrier called private and public. So over here on the private side, I can do it however I want. I can make it a string if I wanted. Right? I could. And you know, have the string 3.1415, you know, and you essentially implement an infinite precision floating point number using a string if I wanted to. And you would not know it, because when you call get radius, you get a float. Okay? You don't know. There's this separation of concerns. I can do my thing over here, you do your thing over here, and as long as the interface is consistent, you know, you get a point when you ask for the center, then everything is chef's kiss, works great. Okay? You can do your stuff, I can do my stuff. We don't need to know intimately what each other's privates look like. So you don't have to put bounce checks everywhere. You only have to put it when it changes. Exactly. Because otherwise, in your main, every time you use radius, you'd have to be like, is it negative? Is it negative? Is it negative? And now you don't. All right. So a couple other what I'm working on right now is not a pod. This is a something called an ADT, an abstract data type. So I am making a circle. You don't know how I've implemented a circle. That's why it's called an abstract data type. I am making a circle. You don't know what my private variables look like. It could be a double, it could be float, it could be a string. You don't know. It's abstract. All you know is that there's an interface, and the interface says you can get a radius, you can get a center, and that's all we have for now. You know, but you know, we'll do more with it. Okay, so. This is an ADT. This is the alternative to pods. This is a pods, right? Pods is just plain old data. It's just data. There's no, you know, none of this stuff on it. Okay. Okay. So void set center, and this is going to take a vector 2D called new center, and we will simply say center equals new center. Should this be called by value, called by reference, or called by const reference? The class with no getters or setters, the definition is a little more complicated than that. No constructors. Everything, all the member variables are public. Is kind of the main thing to a pods. Like all your member variables are public. You don't have constructors at all, and then it is a pod basically. You could technically do a getter and setter if you have public member variables, but why? You know, because you can just get and set them directly. .x, .y. Instead of .getx, .getY. Const reference it is. Very good. Const vector 2D. And there we go. Now, why const reference? Because this is a non-primitive. The rule is anytime you pass a non-primitive to a function, it should be const reference by default, unless you need something else. Right? We're not changing new center. Right? So it most definitely should be a const. Right? So, and why by reference? Because anytime you pass in a non-primitive, it will make a copy. And so if you have a circle, right? This is 3 variables, which isn't too bad, but it could have more. if you just make a copy needlessly, you're copying all of those variables every time when you don't need to. Pass it by reference. It passes a pointer instead of duplicating the thing, right? It's like if you got a box full of rocks, it's easier to just move the box full of rocks 1 meter over rather than going and finding equivalent rocks for each one and making a whole brand new box. Okay, you got a quartz, I'll put a quartz in there. You got a topaz, I'll put a topaz in there. And then you set a thing and you throw it away. That's call by value. Call by value is duplicating every member variable in a class and then throwing away the duplicate when you're done with it. So it's needlessly wasteful. Needlessly wasteful. Call by value is fine for integers because it's just an int, who cares? Copying an integer is faster than passing a pointer to an integer because an integer is 32 bits. A pointer to an integer is 64 bits on the system, so it's faster to just duplicate an integer. But for, like imagine you've got a vector full of 1 million ints. Do you want to duplicate all 1 million ints and throw it away? Or do you want to just use the original one? But if you use the original one, it could get changed. That's why we pass it in as const, so we can't change it by accident. It's just, we get the speed without the risk. So, one thing we need to talk about is shortcut notation. Shortcut notation for constructors is preferred because of consts. Okay, so rather than doing this, radius equals new radius, center equals new center, there's something that I call shortcut notation. It's technically called like an initializer list or something like that. And you basically give a list of variables and you tell how to construct it. Center. So what this is doing, it's actually chaining the constructors together. So the constructor of circle here is going to call the constructor on radius. Integers have, or doubles have a constructor that takes another double. And so it's going to construct radius with the value of new radius, and it's going to construct center with new center. And the reason why this is important is because what if radius was a const? Yes, I know set radius doesn't work now, thank you. Yeah, we'll get to that. But let's say that radius was a const. You can only set a constant variable once. Do you guys know when you can set the value on a constant? Like constant x. How can you give x a value? What is the one time you can set the value of a constant? When you make it. Very good. Yep. So if I say constant x equals 10, that is the one and only time at the moment of birth, at the moment it's constructed, it is constructed with a value of 10. That is the only time you can do that. You cannot do this. Right? Even though it's the same code, right? You can't do this because it's been born, you can't change it, it's carved in stone. Constant variables cannot be given a value after the fact. Okay. So, what this is doing here will actually work. You see it's compiling fine because this is the moment of construction. At the moment of construction, at the moment of birth, radius is given the value of new radius. If I did it down here, it actually won't compile. It's too late by this point. Even though we're in the constructor for the class, by the time we're in the constructor body, all the member variables have been constructed already. So the only way of setting the value of a constant like this is through this shortcut notation here. Okay. An uninitialized constant primitive. Yeah. Yeah. Right. Yeah. It's pretty bad. Const int x. Doesn't like it. Yeah. Default initialization of it is not a fan. It is not a fan. Let's put it that way. Okay. So yeah. So you can only set the value of a constant once, and that's at the moment it is created, the moment of construction. And then we can still check to see afterwards if it was given a improper value and throw. All right, so we can just say if radius is less than 0, throw an exception. And now here, this won't work because radius is a constant. So there's literally no point having a set radius function if the radius is fixed in stone, right? Like this would be a time where you just would not have a set radius function. You usually have a get and a set for every member variable. Every member variable you have, normally, by default, will have a get and a set for it. Get the value, set the value, and you enforce the contract, the invariant. But sometimes you don't. Like if radius is a constant, like for whatever reason, we just need to be absolutely damn sure that it will never change past the moment of birth, then we just wouldn't have a set radius function. You guys understand? Like, it would just... Why you know, if it's set in stone, we just don't have a set radius. Okay. You still need the first constructor. Yeah, I mean it'll create a point basically. You know, it'll make a circle that has a permanent radius of 0 and at x and y 0. I mean those could change, I guess, but it's a point. If you make a circle with no parameters, it'll just make a point for you. So, but we don't want this to be const. Make it like that, and then that's fine. Now, while we're on the topic of const, what if we made Bob down here const? Would I be able to call set radius on it? Right, radius is no longer const, but Bob as a whole is const. So everything's off limits now, right? Can't set. I'm not going to be able to set the center. I'm not going to be able to set the radius. Nothing. It's set in stone. It was constructed, boom, and it is now fixed in place, right? So this code, when I hit escape, it's going to yell at me. This argument to member function set radius has type const circle, but the function is not marked const. So, and that's a better error message than what G++ gives you. Watch this one. The error that we get to this is error. Passing const circle as this argument discards qualifiers. Oh no! Discarding qualifiers! What does that mean? Is usually the mindset of most CSI 41 students. No, I don't want to discard qualifiers. What is it? I don't... Why? What is a qualifier? So in C++, there's two qualifiers. They're called CV qualifiers. One's called const, which you're familiar with. The other's called volatile, which you're not familiar with, and we probably won't even touch until CSI 45, if that. So if you violate the const qualifier, that's what it's saying there. You're trying to change a const variable. And so rather than just saying, hey, this thing's const, you can't change it, they say you're discarding qualifiers. Which sounds a lot scarier than it actually is. And Hazelton's like, if this was JavaScript, you could change it. Well, just so you know, we could const cast to a circle, Bob, and then set the radius on it. Okay, so yeah, you can actually remove constness from a variable. I've literally never done it though, because it seems like a really bad idea. You can technically const cast things. Again, this is one of those things where there's like some weird, niche cases where, there's probably some reason that I've never had const for. Like you're calling some old library and the library is returning a const variable. And you're like, I need this not to be const or something. I don't know. I got nothing. So this code's still not compiling though. So check this out. It's complaining that get radius. Do you guys see this? Set radius we understand, right? Like you can't set it. Fixed. It's fixed in stone. You can't set it. Why can I not get it though? Like I'm reading from it. I'm not writing to it. Why? Well, because C++ has a rather bizarre system where right here, in between the open close parentheses and the open close curly braces, they have a requirement of marking constant methods. This means this function won't change any member variables. Okay? And you can only call constant methods on constant headers. Should all be marked const. Side characters should never be marked const because it makes no sense. Okay. And so it's that right there. And that's a weird place to put a keyword, but it's the only place they can think of. Because if you put it anywhere else, then it would mean like you're returning a constant float or something. So this is called a constant method. And you can see down here, it's compiling now. It's compiling because you can only call constant methods on constant variables. Okay. You can only call constant methods on constant variables. So proper class design is all constant methods should be marked const. So that's one of the big things. Okay. If circle bob was not a const, the function, so it works fine. Constant methods can also be called on non-constants. Okay. Non-const variables can have both const and non-const methods called. So we can both get radius on Bob and we could set radius on Bob to, let's not do negative, 10.1111. Okay. So yeah, there's no downside to marking something as const. If it doesn't change a like if your method doesn't change any of the member variables, it should always be marked const. That will enable it on constant variables of type circle or whatever. Always, always, always make accessor functions const unless you're doing something really weird, right? If your accessor is changing the like if you're calling get radius and you're changing the radius, that's probably bad class design. Yeah, in general, your accessors should always be const. And everything that doesn't change everything that doesn't change the thing should be marked as const. So, for example, for the next thing we're going to do, we're going to be making a function called within, and it's going to be taking again const back to the reference point, and this function is going to be return true if point is inside our circle, false otherwise. And so this function here, vac2d, so this function, is this going to be modifying us? Like if I say, hey, is this point here, you know, is this point here within the circle, is that going to be changing the circle? Is the center going to move? Is the radius going to move? If I'm just asking like, hey, is x inside of you? What do you guys think? Should this be marked as a constant method or not? Yeah, yeah. If that modifies the circle, there is something really bad going on. So yeah, this should be marked as const. All right, and so it's not just accessors; it's anything that doesn't modify radius or center should be marked as a constant method, and that's one of the rules of good class design. Okay. Now, do you guys remember geometry? Do you guys remember how to determine if a point is inside of a circle? So let's say we got the center of the circle here is at 1020. Its x value is 10. I don't want to call this point x. That seems like a bad idea. X's x value is 7. Let's change that. Let's make you point. Okay. So points x value is 7. Points y value is 20. Our circle here, Bob. This is Bob. I don't know why it's always Bob. The center of Bob is at x10, y20. It's got a radius of 5. So this is not to scale. It should be over here, right? So the point, though, is 3 away from the center, and the radius of the circle is 5. So is the point within Bob true or false? It is. It is. And we know that because the radius is bigger than the distance. That's the comparison. If this is bigger, So if we have a circle of radius 100 and our point is 1 away, we're inside the circle. And we use the Pythagorean theorem to compute the distance. In C++, this is called Hypot because people get high on pot. And basically, you subtract x1 and x2. That's the horizontal distance. You subtract y1 and y2. That's the vertical distance. You square them, add them together, square root it. It's the Pythagorean theorem. That gives you the distance from here to here. Okay. So in C++, there is a function for that. And that function is called Hypot. So double Hypot from point.x minus center.x, point.y minus center.y. That's how far away the point is from the center. And so if you just return point less than or equal to radius. And you need CMath to be happy. And what else we got going on here? Why are you not happy? Oh, sorry. Double distance equals Hypot. There we go. There. All is right in the world. God's in a 7. All's right with the world. There you go. There's a setup for that. Okay. So, if you haven't seen Evangelion and you're an anime nerd, you should watch Evangelion. It is a good anime about giant robots, except it's not about giant robots at all. It's about human psychology. I've seen I saw the remade series and that was pretty good. I haven't seen the movies. I've seen part of them. I kind of want to watch all the new movies. I hear they're pretty good. Okay, so what are your thoughts on Attack on Titan? I watched the first season of it. It's a very well made anime. It's depressing. Like, yeah, like there's no two ways about that. It's a depressing anime. It's good. It's very well made. The Attack on Titan apparently came about when the manga artist was at like a late night internet cafe, and like a drunk guy walked in. He was like kind of staggering around the room, and he was like, he had this moment of horror of like looking at this like alien creature, like crashing around. And that's kind of why I think the Titans move that way. They just kind of move around like drunk people, like smashing into things and kind of playing on that sort of body horror of somebody who's kind of out of control and wild and bigger than you and stuff like that. All right. It is. Like, yeah, if you're, like, if I was playing World of Warcraft or something and a guy just, like, started crashing into chairs around me, I'd be like, what the hell's going on, you know? So, you're basically watching drunk people that are eating people. Yeah. Okay. So those are the rules. So basically, a class's data plus operations we can do on that data. So for this circle class, we've got to get a set, and we've got within. Typically, we typically, not always, but we typically write overloaded operators as well. Overload operators that make sense. So for example, for the fraction homework, you're going to make plus work on it. So you could add, if you have a fraction A and a fraction B, you could add them like that. But usually, the stream insertion and stream extraction operators are the operators we typically write. So for example, by default, C++ doesn't know how to do anything with your classes, right? If I had vector 2D A and B, and I tried saying like A is equal to A plus B, this wouldn't compile because it's like, I don't know how to add them. How do you want me what are they? I don't know. You know? I don't know what do you mean? What is it? I don't know. You know? Or likewise, if you tried like couting, if you tried like to see out, you know, the thing, like it's like, how do you want me to print it? I don't know. Like, you know, like you know, you want it to be like, have a parentheses or whatever and a comma. It doesn't know. And so by default, if you try doing something like cout bob.get center, like that, it won't compile because it does not know how to print a vector 2D. And you can see the error message here: invalid operands. Every operator is actually a function call. Every operator is actually a function call, and a lot of them are invisible. They're built in. Like if you add two integers, it's a built-in function call. You don't see it. But this is a function call to operator double left arrow, because it's the operator is double left arrow. So it's literally a function called operator double left arrow, like operator less than. And it is a function that takes two parameters. The first parameter is the left-hand side here, just cout. The second parameter is the center point of Bob. And so you can see here, it's like, I've never heard of this guy. I've never met this man in my life, says Loki. Right? A function called operator double left arrow that takes a no stream on the left and a vector 2D on the right. Never heard of it. I don't know how to do it. Won't compile. So what we can do is we can teach C++ how to print a vector 2D. And there is a standard way of doing this. It will look like hot garbage, but memorize it because it's useful. Or write it down somewhere in your notes or something. So it's going to look like this. So we're making a function called operator double left arrow. And it's going to return cout. And the reason why we return cout is because this function runs, and then it returns cout, so that it then couts the inline. That's what allows you to chain together multiple cout statements, is because it returns, the return value is ostream also. And it's going to take as the left-hand side parameter outs, and that's going to be cout passed in there. And it's going to take in a const vec2d by reference the right-hand side. And so now you get to tell it, when you print a vector 2D, how do you want it printed to the screen? And so you just say, give me an open parentheses and rhs.x, and then a comma, and then rhs.y, and then a close parentheses. So that's how you print a vector 2D. It'll do 3, 4 with parentheses around it. And then we need to return outs. And so you could do this, return outs, or if you wanted to be super cool, you could do that too. So this whole thing is an expression that will evaluate to outs, and so then it returns. If you want to be extra elite hacker dude. Or dudette. No, dude's gender neutral. That's fine. Hacker dude's fine. So now, when you come down to the bottom here, you see it's compiling. And it will print out 10.1, 20.2. Voila. So this is really, really important. Why put this inside of vector 2D? Great question. So the friend keyword here, normally what friend does is it grants your friends access to your privates. Okay, so normally if you had a friend function, it would give access, like for circle, it would give, like if I said friend Alex, right? Just like that. Then if I make a function, called Alex, what that does is it grants Alex permission to the private member variables of the circle. So let's make it take a circle. And then I could do things like say yo.radius equals -10 or something like that. So by default, what friend does is it grants people outside of the class access to your private member variables. Okay? Only you and your friends have access to your private members. Okay? So in this case, though, I'm not really using friend for that reason. I'm doing it because it's a pods, right? So this is everything's public. There's no reason to use friend for that reason. And in fact, I could do this, right? Like I could do that, and it would compile down here. You see, it's not complaining. Everything's right in the world, right? All's right with the world. So why did I make it a friend function? Well, because I do it both ways, by the way. But the reason why, to answer your question, Portnoff, why I put it inside of the Vector2D class is because it makes sense for me for the Vector2D class to have inside of it how to print it to the screen. Okay. So what are you mad at? Must be a binary operator. Did I break something? What happened here? Oh, yeah, it's got to be a friend. Okay, great. Yeah, and so if you use the friend keyword, this is actually a function outside of the class. So this, by making it a friend, I'm not using it to gain access to privates. I'm using it to be able to put it inside of the class. So the friend thing indicates this function is actually not in the class, but I want it in the class. But it can't be in the class because the first parameter here is part of OStream, so it'd have to be added to the OStream class, and I can't touch it because it's part of the standard library. And so this is just a clever workaround to get around the fact that I want it inside of the class, but you can't because it's technically a global function. Okay, so does that make sense? So you guys understand what friends are for now? Excellent. So in this case, I'm just taking a global function and putting it inside of the class so that it's all kind of packaged together. It kind of looks better to me this way, philosophically speaking. But it's essentially the same thing as that global function outside of it. All right. So, yeah. And so we can now get center and see it out and stuff like that. So typically, we will write double left arrow operators for classes if we want to see out them or see in them, stuff like that, right? So if I want to make a CN overload, again, I'm going to make it a friend, not because everyone has access to there are no privates. Vector2D doesn't have any privates at all, right? It only has publics. So the friend in this context is, again, not to get access to the privates. It's just so that we can have a global function inside of the class. So operator, double right arrow. You can't put it inside circle for this one? Or are you talking about the Alex down below? The friend. What friend? This friend? Or the circle's friend? We've had 3 friends. We've had a lot of friends. So ends, double right arrow, first friend. This one? Yeah, there's no reason for this to go inside a circle because this is teaching us how to see out a Vector2D, right? It has nothing to do with circle. This is just how to print a Vector2D to the screen. Now, some people do this, by the way. They'll do like a void print function, and then they'll like see out X, Y. Like that's pretty common too. Like people that are from the Python world or whatever, so that you can go like bob.print, and then it'll just print the X and Y values to the screen. Probably doesn't require you to memorize something that looks like hot garbage. I typically just overload the double left arrow and double right arrow operators. Okay, so if we want to overload the double right arrow operators so that we can CN into a vector, then it would be ends into RHS dot X and RHS dot Y. Why is this not constant? Friend allows access to all of your private members, not just one. Total access. Because we're writing into this variable, right? We're changing RHS. Right? So if you wanted to read from the keyboard into Bob's center, we could say cn bob.set get center. Wait. Let's do this instead. Vector2D temp cn enter temp. Okay, see that? Because every operator, plus, minus, subtract, same as minus, the unary minus, modulus, square brackets, all of them can be overloaded. In this case, and they're just a function with the name of operator plus, operator minus, operator double right arrow. And so this is going to call a function called operator double right arrow, with the first parameter being an I stream and the right parameter being a vector 2D. And so we do that, and then we can say bob.set center to be temp, and then we will output the result. So if we do this, 1020.111, you can see that it gets set properly. Okay. So, yeah, the reason why this can't, you can't make this const reference is because we're changing it, right? You know, const means we're not changing it. If you're outputting a variable, it shouldn't change, right? Like if you see out a variable and the variable changes, you're like, what? That doesn't make any sense. But if you're writing into a variable, then yeah, it can't be const, right? Because we're setting RHS, you know, .x, right-hand side, by the way. RHS is just right-hand side. There's the left-hand side of the operator and the right-hand side of the operator. If you want to, you can call that LHS. You know. Just for consistency's sake. Sounds like a high school. You know. Did you go to RHS? Oh, wait, no. Did you go to LHS? Okay, so last half hour of class, you guys are going to make a... You went to LHS? So for the last half of class, until 4, let's say, I want you to do this. Except I want you to make a rectangle. I would like for you to make a rectangle class. So think about what describes a rectangle. For a circle, it's the center point and the radius. But a rectangle is not a circle. So you need, in my opinion, 4 variables to describe or 2 points, you know, to describe a rectangle. Bottom left corner, top right corner. Or you can have bottom left corner and width and height. There's different ways of doing rectangles. Be aware that this is probably going to come up on your next homework assignment. Not the current homework assignment that was given today, but the next homework assignment. We're going to do something with rectangles. And I haven't decided yet. I've got 2 different ideas, and I don't know which one I'm going to do. But be aware that any work you do today is going to be useful in the future. That said, it's lab time. Feel free to screenshot what you're doing and share it with your friends. Lab time, you know, it's not a homework assignment. Feel free to screenshot, ask for help. I got a gardener now blasting his lawnmower outside my window. Which, at least it's not the beginning of class. So feel free to share, ask questions, and I want you to basically follow this pattern, right? The rules here, you know, make a private member, start by making the private member variables, then make the constructors, the getters and setters, and then I want you to write a within function for a rectangle. So how do you know if a point is within a rectangle? Think about it. Okay. What's homework for today? It's called fractionation, and I guess we'll go over that. Then I don't need to come back in at the end of class. So named after the Janet Jackson album, of course, Rhythm Nation. And so this one's a little different. There is no main.cc. You're going to build the assignment by typing make to build it. There is no main.cc. There is a file called do not edit me.cc that you can't edit. Don't edit it. Don't modify it at all. You can look at it. You can read it. Don't edit it. You'll get a 0 if you edit the file. So this is a program that will test your class. Your class is going to be in fraction.h, and it's already kind of done for you. It's got a new, like, what describes a fraction, right? A numerator and a denominator, right? That's done for you. It's got a default constructor done for you, private section, public section. You need to write, though, the 2-parameter constructor. It's got a get methods that are done. It's got set methods that are done. but you need to write the double left arrow operator. Do you guys understand? So it's like a skeleton of a class that's like half done for you. It's a half-grown skeleton. You don't have to do all this stuff from scratch. Half of it's done, and you can look at how I did stuff and copy it and model it for yourself. So the double left arrow operator, right now, if you try echoing a fraction to the screen, it will say omae wa mo shinderu, which means you're already dead from Fist of the North Star. That's incorrect. If the fraction is 3/5, it should print 3/5, not omae wa mo shinderu. All right? So, did I? No. Omae wa mo shin. Yeah. Okay. All right. Okay. Thought I had a typo in there for a second. All right. So, the double right arrow operator is already done for you. You're gonna have to do this. So anywhere in the code where it says you, you're gonna write the code. Okay. So you need to write a reduce function. So if somebody passes in 2/4 and they call reduce on it, it should turn into 1/2. Right? You guys remember 3rd grade, 4th grade fractions? If somebody gives you 3/9, it should turn into 1/3. The standard library has a greatest common divisor function. That exists. It's also got least common multiple called LCM. So code exists already for GCD and LCM, and that's going to be useful because you're going to be adding fractions too and subtracting fractions. And so if you want to add fractions, you have to find the greatest common denominator, or the least common multiple for the denominator. You have to find a common denominator. So if you add 1/2 and 1/3, the common denominator is 6, right? And so this would return 6, and then we convert 1/2 to 6th, so it becomes 3/6, and 1/3 turns into 2/6, and then we add the numerators together to get 5, and so we return 5/6. Okay. So the plus operator is already done for you. You have to write, however, the minus operator. So this is extremely challenging because it's like 5 lines of incredibly dense code, but you've got plus. Plus is already done. I'm not going to tell you what you need to change in order to get minus working, but it is very similar to plus. Plus and minus are very, very close. I'm not gonna do it for you, but just be aware that it's only one character you need to change. Copy and paste it and change one character. I'm not going to tell you which one though, but it's one character you need to change to get those points for doing minus. Okay? And then once you do that, you should be able to figure out multiply and divide as well by looking at the code and kind of figuring it out. Okay? If you guys remember, 1/2 times 1/3 is 1/6. Okay. The subtext there is, I know. I don't want to make it easy for you, Margaret. That's why I'm being kind of cryptic. I don't want to just hand you the answer and just show you what you need to do to get minus working. Okay? It's very complicated. Okay, so if you want to know how to search, by the way, so if you want to search for every place marked U, it is / in Vim, YOU, and then N for next allows you to go through the code and look for every place where there is capital YOU colon. In fact, let's just search for YOU colon. That will take you to each place in the code where you need to write code. And once you've done all that, you're done. Okay. So, and if you hit return, it turns off highlighting. So, when you do a search in Vim, it turns the yellow. And so if you hit the enter key, it does a colon no highlight. All right. So that's your next homework assignment. In the meantime, in lab time, I want you to follow this pattern for circle and make a rectangle class. Okay? Fractionation is due next Friday. After that, you'll get your next homework assignment, which will involve the rectangle class you're making here. Like I said, I haven't decided quite which I'm going to do yet. I kind of want to see how you do on this one first. Nani? All right. So I'm going to stop the recording here for today. Have at it. Post screenshots. I don't want you just sitting here during lab time. I don't want to see anyone logging off. Like, there's 41 people online right now. I see each and every one of you. Don't log off. Actually do the lab time. Actually write code. Like, you can't get good at coding unless you write code. You have to produce code. And if you don't even know what to write, start by just copying me, right? Like, start with this whole circle thing, and here I'll even copy and paste the vector 2D for you, so you can do this. You can write it anywhere you want. This is lab time, so lab time is it's not graded. You just make a new file. Vim foo.cc. It'll open up a blank file. There's my vector 2D class. Feel free to copy and paste it. And so basically, use this as a template. So use my circle class as a template, and think about what makes a circle and a rectangle different. Okay. And just follow from there. So, any questions about this? I want to see all 41 people still online by the end of class. Okay. And if you're stuck, post on the Help Center. Post screenshots of your code. Feel free to share your code. It's not homework. You can't share your homework with your friends, but in lab time, it's a-okay. Okay. All right. Any questions? If you're learning, this is a very important lesson. So make sure you do it. Plus, it'll come up on the homework. So, yeah. All right. Begin. Let the games begin. All right. I want you to make a class. I want you to make a rectangle class. Okay? Not class circle. I want you to make class rectangle. That has a within function that will, you pass it a point and it tells you true or false if that point is inside of the rectangle. Okay? But getters, setters, constructors, shouldn't need a destructor, private member variables, the works. Okay? I'll even post the steps right up here because that's going to be off screen. Okay. There you go. And hell, I'll just give you all this. Why not? Yeah. No, I want you typing it from scratch. It'll be a good mental exercise to actually get everything down. If you copy paste, it's not going to give you the muscle memory of it. But I'll leave it on the screen. All right. That is it for today. Work hard on the Zybooks. Zybooks are due on Monday. There's a lot to the Zybooks. Don't wait to the last minute on it. It is a gigantic Zybook. It's probably the biggest one of the semester. So go hard on that. That's why I waited on this homework assignment, so that you could have more time to work on the Zybooks, not overwhelm you. All right. Peace out, you guys.